Hello, my name is Seonyong. I am currently attending Chungbuk National University, Department of Information and Communication Engineering. The presentation topic is a Fintech platform for next generation credit card payment. This is index of the presentation. This presentation goes from the introduction to the conclusion sequentially. Fintech is a new financial technology, the new technology and innovation that aims to compete with traditional financial methods in the delivery of financial services. Blockchain is continuously growing list of records called blocks, which are linked and secured using cryptography. Each block typically contains a hash pointer as a link, a previous block, a timestamp, and transaction data. Blockchain or distributed ledger technology is promising to bring trust and transparency to world filled with uncertainty and the threat of fraud. Large financial players are collaborating in consortium to rebuild infrastructure based on this new technology to replace legacy and incomplete systems. From trade finance platforms to cross-border payment to digital identification, eliminating ineffective created by lack of trust and transparency is a major selling point of implementing blockchain technology. By removing those intermediaries in business processes and creating innovative networks, blockchain is streamlining the exchange of value across ecosystems. Blockchain technology promises to provide an encrypted distributed ledger that is verified in real time, enabling fast and reliable international payment services without intermediaries such as banks or exchanges. Although blockchain was born as the underlying technology of Bitcoin, it is now being applied to various fields that require a reliable ledger. There are two main areas of blockchain applications that may see live deployment and may have implications for business. International payment processing services involving bank-to-bank transfers and trade finance applications. Those areas are ripe for disruption because existing systems often are slow. Currently, according to a report by Credit Suisse, which note that today's cross-border wire payment can take days to clear and involve fees as high as 10%. The Fintech blockchain network covered in this study is fusion of decentralized and distributed architecture. The reason we are choosing a coverage approach between distributed and decentralized is because the communication overhead on totally distributed computing environment is very high. Performance improvement of blockchain platform alone cannot meet current global blockchain research and development trend or direction. Meanwhile, the reason we do not fully depend on the decentralized architecture is that it's difficult to realize the decentralized control architecture that is inherently targeted in blockchain. Blockchain and tokenized are very important this disrupted trend in the payment sector of the fintech industry. Many blockchain and fintech-based mobile banking startups are opening in the Silicon Valley. From the trends in the field of fintech, we need to design a flexible computing platform rather than a distributed or decentralized architecture. Blockchain is effective in preventing forgery and hacking via data manipulation. However, given the blockchain does not have a person identification and authentication techniques, it is impossible to replace the public certificate. For example, the Bitcoin is identifiable up to the Bitcoin wallet, but it does not identify the owner of the wallet. Hence, if you lose your password when using Bitcoin, that your wallet is irretrievable. But however, if you cannot identify the owner of the Bitcoin in the blockchain, it is equivalent to cyber money or virtual money. Therefore, this study evaluates implement necessary biometric technique for identification of the owner of virtual currency of cryptography money. In addition, we discussed an article that considers the need for blockchain to be combined with public key infrastructure, biometric authentication, and other means of identity verification. The current blockchain technology itself is not sufficient to replace the current PKI certificate. Bitcoin is just a virtual currency or cyber money. If blockchain does not support owner identification by a method such as PKI certification. For example, as shown in figure 3, virtual or cryptocurrencies can identify the owner machine, but they cannot identify the specific owner of the machine using blockchain architecture. This is a very significant drawback of blockchain systems for fintech. Our research combined credit card payment with blockchain network if there is no connection with the credit card payment system and blockchain network. The blockchain cheaper, such as Bitcoin, is just a virtual currency or cyber money forever. We must also consider the integration approach in terms of performance. Even the performance of state-of-art blockchain platforms cannot meet the performance of fintech applications in the real world. In order to resolve the performance issues, blockchain networks in processing credit card transactions, we exploit the overlay network concept to separate the credit card from relatively slow blockchain P2P network. R3CEV is consortium established for research and development to utilize blockchain's dispersal ledgers in financial transactions, including foreign banks, including Goldman Sachs, Barclays, and JP Morgan. Since that financial companies have been expanding with additional subscriptions. In Korea, Shin Bank joined the consortium for second time, followed by Microsoft, R2 Unibanco in Brazil, Ping An in China, and AIA in Hong Kong. Currently, the consortium joins the R3 consortium. Visa has shown Ethereum and Bitcoin also provide open source. ChainOS 1 is designed to be more optimized for financial transactions than the previous two transaction Bitcoin blockchains can handle 6 to 7 transactions per second. But ChainOS 1 is optimized for banking, payment, insurance, and so on because it can trade as fast 65,000 transactions per second. Although Visa is designed to be optimized for financial transactions, it is still being investigated for its opportunity in systems often the financial transactions, as it is somewhat difficult to use in other fields. Blockchain CG is community established within the World Wide Web Consortium, an international organization that develops and promotes standards for the World Wide Web, and is the world's first standardized off-chain block standardization group. We are studying standardization blockchains through collaborate the domestic companies, schools, and research institute over 12 countries including USA and UK. The Hyperledger project is an open source project under the Linux Foundation. Ripple, IBM, JP Morgan Chase, Cisco, Digital Asset Holdings, and Rockstream are involved in this project. The project will cover a wide range of open source software in a way that all transaction history is protected by encryption and disclosed to all participants in the network. They are developing an optimized blockchain technology for the enterprise. Proposed technology. Currently, credit card companies autonomous attempt to strengthen their security level. Most recently, the popular approach in Korea is as follows. If purchase amount exceeds 300,000 Korean won, the owner of the card of requirement to confirm their identify via PKI certificate or SMS authentication. Figure 5 depicts the compost for the blockchain core and common service library. We explained figure 5 in the past, the bottom half on the top half. In the bottom half, the Fabric client operate distributed decentralized communication primitives for achieving a P2P network. which is the basis of blockchain. The membership registration and management companies are for management of blockchain networks for tasks which include registration of recognition of members. Chain code is a program written in Go or Java that implement the prescribed interface. Chain code runs in secure Docker container isolated from the endorsing peer process. It initializes and manages the ledger state through transaction submitted by applications. The bottom half is considered a common service library. The top half contains components that provide authentication, identification, payment, and loyalty card service. The loyalty card service represents for point management or membership services. Currently, it is so difficult to apply blockchain technology directly to Fintech owning to performance platforms. For example, the required transaction time in the Bitcoin network depends on the mining state of each block, but it takes 10 to 16 minutes for each block to operate by it prospect and recognized a transaction record. In particular, in the case of block fork situation, where multiple blockchains are created at the same time, it takes about 60 minutes to remove those forks. Specifically, the processing performance for a transaction is as follows: approximately 5 transactions per second on Bitcoin, approximately 25 seconds on Ethereum, over 1000 transactions per second on Hyperledger, and over 400,000 transactions per sec on Visa. In order to resolve such a performance problem, we exploit the concept of the overlay networks on payment processing for credit card payment platforms with blockchains as shown figure 6. An overlay network is a computer network that is built on top of other networks. On other networks, node is the overlay network can be thought of as being connected by virtual and logical links, each of which corresponds to a path, perhaps through many physical links. In underlying networks, for example, distributed systems such as P2P network and client-server applications are overlay networks because their nodes run on top of the internet. The internet was originally built as an overlay upon the telephone networks, while today the telephone networks is increasingly turning into an overlay network built on top of the internet. This is a type of upscaling technique which originates from the offloading technique. We will now describe how we implemented the credit card payment network in our research. For credit card payment processing, we made use of FoCoS.IDIC.20211023.O.Session1.71 payment platform. We check the detail of the transaction through the biometric transaction ID. For this payment on PayPal's transaction detail page, in this study, two ID values are involved when a payment credit card transaction happens. In this study, the payment ID is an internally used ID and the transaction ID is assigned a unique value for each transaction by the PayPal system. Therefore, although a processing delay caused by the slow performance of the blockchain network, PayPal processes the payment through their credit card payment system, then the overall network can check information about the sender of the payment based on transaction ID in the blockchain network for the PayPal credit card payment. Table 1 represents the real mapping between payment ID and transaction ID. The transaction ID is unique ID that is looked up when you click on the detail view on individual transaction in the PayPal administrator console. The payment ID is unique ID assigned to individual transactions in the Fintech blockchain platform developed in this study. Those two IDs are authenticated with each other for mapping onto an overlay network and are stored on a high-performance database. Figure A shows the actual implementation of payment system in this study. Hardware included a terminal computer, printing control-based credit card reader, and summer receipt printer. The terminal computer is connected to the financial blockchain platform or thus the internet. The following configuration in table 2 lists the parameter values applied in this study for driving the terminal receipt printer, a summer receipt printer. Table 2 also lists the parameters that the control board for summer receipt printer is configured with the control board and summer receipt printer are connected to each other by serial communication, RS-232C, USB, and etc. We now present the detail of the data preparation, assessment metrics, and evaluation of our methodology. This section describes the experimental result for the Fintech blockchain platform. This study applied Spring Framework, which is a standard platform for web application construction. In addition, the server was built with an AWS-based cloud computing platform, which is widely used in industry in Fintech. The project management tool used in the study is Apache Maven. Maven is a tool that makes it easy to build development environment through file XML format. MyBatis is an object relationship mapping tool. Java-based objectives used in Spring Framework are applied to relational database systems such as MySQL. Therefore, in a Java program, it is possible to obtain the effect in inputting and outputting through the database in merely calling functions on an object basis. The management tool for a Fintech blockchain system is demonstrated by the capture images in table 4. We make use the Spring Framework based Fintech blockchain management console developed by. In this study, we applied jQuery mobile and CSS3 techniques, representations built on the HTML5 layout, and introduced the client-side script through JavaScript, various server techniques such as Spring Framework, Java, JSP, XML, JSON, Maven, and MyBaptist were applied. Table 4 lists server performance indicators for each image size used for representational state transfer REST API, which is execute a chain code application on the Hyperledger Fabric platform. The number of samples was fixed at 100. The average response time, minimum response time, maximum response time, and standard deviation were described according to the presenting of 100 sample targets. The error rate was 0% in common, confirming that the service was properly performed. Throughput was approximately 83% to 91%. Table 5 represents the request details in terms of various contents types such as text, HTML, CSS, JavaScript, and image. The largest downloading times in Table 2 were owing to the JavaScript and jQuery. This is because currently most websites developed are dynamic. The time to first byte in Table 5 in approximately 234 to 223 microseconds. This is because currently internet communication is based on fiber to the home. Therefore, the response time is almost the same for varying types of contents. The current consumption of the control board device transmitting and receiving the communication transaction is approximately 8.2 milliampere. This is used to obtain the average current consumption over the entire connection sections. We also consider control board current consumption while the device is in slim mode. We found that 0.001 milliampere are consumed in slim mode owing to the characteristics of the board. Therefore, the power consumption can be obtained as least in Table 7. We achieved good power dispatch if we set the communication interval of the control board to 170 milliseconds. We can continuously use the system without charging the battery for up to 134 days. Now conclusion. In this paper, we have described a challenging study involving blockchain and fintech technology. Fintech is a new financial technology innovation that aims to complete the traditional financial method in the delivery of financial services. This study was inspired by the question, what if I could use Bitcoin with my credit card? We believe that such a scenario would result in explosive growth of Bitcoin because of convenience of use, as it would be equivalent to conducting a conventional credit card payment. If the fintech technology does not support Bitcoin, then it is simply a virtual currency. Therefore, we implement integrating between fintech and blockchain technology in our study. Furthermore, we consider the platform in terms of performance, even the performance of state of the art. Blockchain technology cannot meet fintech application standard in the real world. In order to resolve performance issues with blockchain network processing credit card transactions, we made use of the overall network concept to separate the credit card network from relatively slow blockchain P2P network.